Nobody knows it all, but we all know a little something. And if those little somethings came together, we could do almost anything. Like windows that turn sunlight into electricity. It may seem like magic, but it's simply chemistry. The same chemistry that can make plastic bags compostable and wind turbines more durable. Good connections today can make for a better tomorrow. That's why we don't just make chemicals, we create chemistry. BASF, the chemical company.
BASF Case, presented by Giovanna, Manu and Willie. BASF is a German company and one of the leading chemical companies in the world. It offers a huge range of chemical and chemical-related products in the NAFTA region, Europe, South America and Asia. The product mix includes chemicals, polymers, automotive coatings, colors, dyes, nylon fibers, pharmaceuticals and agricultural products. The company has a presence in several different industries, such as aerospace industry, automotive, agricultural, healthcare, food and beverage, and so on and so forth. BASF Corporation is the North America NAFTA region member and it's part of BASF Group. This optimization case that we are going to talk about was developed by BASF Corporations. So why did we choose this case? What's interesting about it? Well, this case is closely linked to what we learned in the supply chain management module. It's not only a typical transportation problem, but it also links with the customer service levels as one of the constraints in deciding the optimization in terms of cycle time and total cost. The problem presented in the case is so important for BASF and for other companies as well, because it has two areas to cover: cost savings and customer service. So let's talk about the problem. What made BASF decided to develop an optimization model? In the 1990s, BASF Corp used 135 shipping locations, from which 86 distribution centers, to which its shipped goods was delivered to customers at an annual cost of nearly 100 million. Goods could be shipped directly from plants or tollers to the DCs and from DCs to the customers. Flammable temperature-controlled products required special storage at the facilities. Imported products were 1/3 of the DC volume. So overall, they had a very inefficient distribution, an outdated distribution network, resulting in shipped goods next day deliveries being of only 77%. The trade-off between customer services and cost savings was what drove BASF to decide to develop an optimization module to reduce cost and enhance customer satisfaction. So the company needed to reconfigure its distribution facilities to serve customers more efficiently and to save costs. So they decided to develop a strategic resourcing planning tool for assessing the cost versus service consequences of distributing packaged goods in North America. BASF's objective was to define the optimal number and location of warehouses and the corresponding material flows needed to meet anticipated customer demand and required delivery service times at the lowest overall cost. So the company made a three-step development: Step 1, Step 2, Step 3. Step 1 englobes the decision variables, objective function and constraints. They decided to go for a single each-alone model that minimized the sum of costs, such as cost of production, transportation and storage costs. The decision variables were many, such as amount of product Y produced at plant J, volume of product Y shipped from plant J to demand market L, throughput of product I at distribution center K, fraction of capacity utilized at distribution K, and others such as fraction of special type of storage capacity M utilized at distribution center K, unsatisfied demand of product I in demand market L. The objective function created looks very complicated, since it englobes different kind of costs related to different kind of variables and constraints. But as we know, the use of optimization models are not easy. Either it's a very detailed model or a simple model. The challenge is to build a quantitative mathematical model that's realistic enough to help decision makers in this qualitative decision-making process. BASF decided for a simplified approach because of some reasons, such as the creation of the model is very time-consuming to put together all the data required. Tool would be used infrequently, harder to justify a large investment or a lot of spending in trainings. The decision makers feel more comfortable using a simplified approach due to little experience with optimization-based tools. So for these reasons, BASF decided for a simpler optimization model, although it still looks very complicated. So how they did it? BASF key personnel from corporate warehousing, logistic, transportation were involved in the formulation process. Consulting and software services from Chesapeake Decision Sciences were key to help BASF build the formulations. For implementing the models, BASF used MIMI, Manager for Interactive Modeling Interfaces. That's a decision support tool from also the same consulting company, Chesapeake. The constraints were also many, such as all production is replenished and shipped to customers. Demand is fully satisfied with penalty on shortages. All products received at DCs are shipped to customers within a year. The total shipment volume to a DC defines its throughput. DC capacity should meet or exceed the storage area requirements for throughput. And others, such as DC capacity should meet or exceed any storage requirement for special types of products, and balance of a DC special storage capacity and the full capacity. In step 1, BASF could identify the busiest and least active DCs. They also could identify the candidate DC locations and most valuable patterns of transportation flow. In step 2, they set up new variables with the goal of search for the best DC candidates, resulting in a list of potential DC locations which include 40 of the existing 86 DCs and additional new locations. Altogether, these new locations, plus the strategic ones already existing DCs, would help BASF reduce their cost of transportation, handling, storage, and therefore deliver better service to customer. In step 3, they worked on the optimization model to answer questions such: who should each DC serve? What products and what volumes of each product should be stocked at each DC? So in summary, many variables and many constraints were needed to develop a feasible optimization model that could allow BASF to achieve their objective of minimizing cost while enhancing service levels.